Hare Krishna. Hope you are doing well. Let's get started with this expectation computation question, which is going to have some use of the CDF, some order statistics based information, and some integration. Okay, let's get started by building some intuition. So, although it doesn't say explicitly, you can understand that it's an order statistic, the minimum order statistic, and it's easy because it's an extreme order statistic because it's easy to use the CDF technique or the opposite of CDF, which is what survival function. You understand, like CDF is less than equal to, and this over here is the greater than taken into the picture. There's a reason for that because if you have the smallest in a group greater than something, then it means everything else in that group must be greater than that. It's an if and only if bijection. It's equivalent. So using this, the setup is transformed into variables that we already know about. Then we just simply take limits and do the integration and get this. Again, I'm forgetting what the 1 minus CDF is called, but you can understand the approach is similar to dealing with CDF, right? Had it been X order n, then we would have taken directly the CDF because the if the biggest in the group is less than or equal to something, then everything else in the group will be less than or equal to that thing. And then we can make use of the known setup. Another thing is again it is intuitive. We are going from intuition to theory. If we know this, we don't have to explicitly find the PDF and then do the integration. Expectation of a random variable is also expressed, of a non-negative random variable is also expressed like this. In this case, it's continuous, so this is fine. Whether it's greater than equal to or just greater than that, greater than, it's fine. But for discrete random variables, do confirm what the sign is. So you can take this and get to the answer by simple integration because you already know the structure of this from here. So again, I feel like the people who said the question wanted us to go this route because this is a faster way than going one step extra and computing the PDF. But it's also slightly risky because we can see that okay, this is 1 by z square and the domain is from 1, so the expectation is of this thing is actually this integral. But no, we have to stick with the theory. 0 to infinity is the integration, so it means that from 0 to 1, whatever is the value that has to be given. And it's very logical because if you have something, a random variable, in this case, yeah, you are calling it z, and the range of values it takes with positive probability starts from 1, it simply means that anything before 1 it has to take. So even if it is like minus 100, it is 1. Probability of z being greater than minus 100 is 1, and similarly probability of z being greater than 0, and whatever value it is between 0 and 1, that thing, this expression will be 1. It's very logical. But I mentioned it over here because it's a pitfall. When you find up till this point, you can just simply equate it and try to go this route. Just compute this term to get the answer. But no, you have to note the formula carefully and then proceed. So that's it. You can get the answer. Hare Krishna. And going beyond the syllabus, we saw that Arjun was very stressed in his situation in the battlefield, and the student is also perhaps stressed in their situation of preparation for the examination. And this is that moment when God has entered the chat. So essentially, it's a representation of wise words, wisdom coming in our moments of depression. In this case, the student is perhaps depressed about potential failure and the consequences of that failure to live up to certain expectations. Let's see what Krishna has to speak. Take care. Hare Krishna.